Congratulations, Dr. Goodenowe. USA Today's most innovative companies to watch in 2025. You've been working in health and innovation for
over 30, yes. There's no core structural infrastructure and pathway for implementing actual true preventive medicine.
Because if someone was to build that infrastructure, there's no financial incentive because delivering that to people would be really challenging, but yet you've done that. You just said 3,000 doctors are using your testing and products?
Exactly. There are 3,000 people out there around the world, and they're using these products. That's why you're getting these dramatic results in autism and dementia and Parkinson's and so on. And we're learning from each other.
It really stuck out to me that you have a rare disease foundation that gives the children with RCDP free therapy.
Correct.
And the cost of a therapy would be $400,000 if it wasn't for you and your program and the system that you've built.
What kind of society do we live in where we can't actually cover the cost for 100 freaking kids?
Yeah.
Like seriously. Like we're dealing with thousands and hundreds of thousands, millions of people with dementia, and we can't actually just donate to 100 kids. It's ridiculous.
Back to Prodrome science at large.
Mm-hmm.
How does this work economically? Like, who is paying for these technology and these products, and how does that work?
There's two pathways.
Well, congratulations, Dr. Goodenowe.
Thank you.
USA Today's most innovative companies to watch in 2025.
Only took them 10 years.
Maybe more. I mean, you've been working in health and innovation for
over
decades.
30, yes.
I had the pleasure of going to the Restorative Health Summit and seeing what you've been doing, not just in a lab or looking at data, but meeting real people who your work has affected.
Yeah.
And it was one of the most inspirational events I had the pleasure of being a part of. And that came from not just one story, but this whole group of stories, this whole group of people. I mean, the first day we had someone on stage who was diagnosed with ALS, whose scores improved and whose quality of life was improving. And then we had stories of Parkinson's and dementia, people who had, also improved their quality of life after meeting you and working with you. And then the next day was all children's health. We met families of children with RCDP, and that's a serious disease. Those children were told they were never going to walk. Their life expectancy was so short, and they're running in the grass. They're engaging with their families. And autism, there was a parent who said how much your work has helped his daughter, who was nonverbal, and now she's singing and telling jokes. I mean, this has gone beyond a one-off. All of these stories. And then Lisa Grillo, she was legally blind.
Yeah.
And at this Restorative Health Summit, she showed that she had been able to regain her vision after 30 years of legal blindness in her eye.
Yeah.
She talked about her experience reading the eye chart and how her doctors were so surprised. How did you do this?
Yeah. So the Restorative Health Summit was really a tipping point on many, many levels. It's the culmination of over 30 years of research. Mm-hmm. And I started research like a regular research scientist did, right? Went through my school, PhD in neurochemistry, looking at the biochemical mechanisms of drugs to treat psychiatric disease. And so I was built, like everyone else was built upon all the predecessors of science. And in the 1990s, the genomics revolution was happening, and we were starting to change the way we looked at research. Previously, research was always hypothesis testing. Like you'd have an idea, you'd have a hypothesis, you would know in advance what you're going to test for, and you're going to validate whether or not that hypothesis was true or valid or false, right? And that's called hypothesis testing. But in the 90s, when we started looking at full genome sequencing and we started looking at the entire large data, so the era of big data began, where people started saying, well, let's just collect the data first, and then from the data, determine what's happening. And we did this for functional genomics and plants and animals and so many things. And however, there wasn't a counterpart to the genomics revolution. There wasn't a biochemical revolution, if you will, that we could actually measure comprehensively all these biochemicals in human biochemistry. And that's where my first real invention came in. I invented a technology using advanced mass spectrometry called ion cyclotron mass spectrometry that enable us to measure thousands and thousands of molecules simultaneously, which is basically the biochemical output of the human biochemical system. How you're operating at this point in time, given whatever environmental, nutritional, variables are affecting you at this point in time. And it's extremely powerful. And of course, the technology was then initially applied to traditional diagnostics and therapeutic research, which would be, okay, since we can measure thousands and thousands of molecules for the very first time, we should be able to diagnose disease much more accurately than ever before. And that is absolutely true. So this technology allowed me to develop diagnostic tests. Multiple patents were filed: colon cancer, pancreatic cancer, ovarian cancer, dementia, Parkinson's, autism.
Wow.
All these diseases had a very clear biochemical signature, which made logical sense, right? So if you can, since our bodies are biochemical in nature, if you have someone with a disease, that disease obviously is going to alter their biochemistry. And so if you can measure biochemistry, you should be able to measure that alteration. Sounds simple, and it's true. And so, but the premise was, my mind at that time was that there's a disease, there's a tumor, there's pathology in your brain, like you amyloid plaque, or you have, neurofibrillary tangles or tau formation, so on and so forth. All these pathologies that we know about in disease. And the mindset at that point in time for me was, well, these things must be doing something bad to you. Like, you must have these pathologies should be altering your biochemistry. And since I have this great tool now to measure biochemistry, I should be able to compare people with a pathology, like cancer, to those who do not have a pathology. And I should be able to identify the biochemical differences between the two. Extremely powerful. And that turned out to be absolutely true. Very, very powerful diagnostic capabilities. But the next step was, well, if the pathology is actually causing this deviation from health, right? Because we're measuring biochemistry. So basically it's affecting you. Something is inside you negatively affecting you. Mm-hmm. If I remove that negative from your body, then that biochemistry should now restore itself. So removing the pathology of a cancer should restore my biochemistry. That's the logic. Well, it turned out that didn't actually happen. It turned out that you remove the pathology, the biochemistry remained the same. Mm-hmm. And that was the first real indication that, oh my goodness, we got this backwards. This is going to change everything, because the cancer isn't what's actually causing your deviation from health. Your deviation from health is causing the cancer. And that when I remove the cancer, you are still at that same stage. There's a reason why you got cancer in the first place. Like, it wasn't some random event. We could predict. So rather than actually measuring cancer, what we found out we were measuring was we're measuring people who get cancer. Two and very different concepts. And so that's kind of where the aha moment came in, saying, holy crap. Like, there's, we can actually, this is where the Prodrome concept comes in, because we can actually see the future now. And then that leads to the next phase of saying, okay, now that I can see the future, can I change it? How do we deal with the biochemical restoration? And from that, everything changed, and your whole mindset changes step by step by step. And that's kind of where it started.
So your aha moment was, it's not disease that makes us sick, it's losing health.
Correct.
And you said that's the Prodrome concept, and your company is called Prodrome Science. So what is a Prodrome?
So a Prodrome, very simply, is that which comes before. For example, you get a barometric change in the weather, and it can predict a future storm. So basically, it's something that's present today that has some level of predictability of what's going to happen in the future. So that's the Prodrome of the future. Normally, when we think of prodromes, we think of them in a negative sense. Okay, what's going to predict some impending doom in our lives, right? But prodromes also have a positive aspect. They can actually predict positive futures. So if you have a good job and you're making more money than you're spending every month, that's a prodrome to a healthy financial lifestyle going forward, because you're making more than you're spending. Versus the opposite, which is predictability of bankruptcy, if you will. And biochemically, we are kind of at that stage. Like, what we do is really biochemical accounting, if you will. We're actually looking at biochemistry as the measure of your total health. So prodromes basically predict that, and they're agnostic. And so you can choose to look for negative prodromes, or you can choose to look for positive prodromes. And so we have obviously said, we can predict the path of, say, a deficiency. Now we can restore that. When we change your biochemistry, we change your prodrome, which puts really the power is in your hands now to not just alter your today, but alter your future.
So the knowledge that you and the data that you're able to generate allows you to see patterns or prodromes that could kind of predict, your health outcomes. And you're saying this knowledge is a good thing because you can act upon it.
Yeah. It's like biochemical engineering. It's like taking your car into a shop, plug it in, and they do a diagnostic check. They can identify which systems are working, which systems are not. And so identifying which systems, so in the previous world, you'd identify some system that's not working properly, and you would trigger a future diagnostic or diagnosis of colon cancer, pancreatic cancer. In the restorative health world, what we look at is saying, okay, so how do I put that back into the original operating specifications? And so we can now, and since it's a biochemical integrated system of biochemical intermediates, we can now plug in those intermediates to not just restore to normal operating conditions, we can actually restore them into reserve capacity and vitality systems, which can then predict your future subsequent improvements so that you can continually improve. Like for example, my brain has continually improved now since I started these programs, and we can monitor that with MRI.
Yeah, it's like we save for retirement, and there are these systems in place to, help us do that. But you're saying now we can understand our current state of health and plan accordingly for the future.
Exactly. We can predict the future. So if you're saving $1,000 a month, okay, that's today. Well, a year from now is $12,000. 2 years from now, it's $24,000. And so now you can actually predict your future. You can actually predict if I stay on this current path that I'm on, I will have X number of dollars saved up. And so if you are restoring brain structure and function, if you're restoring your neuromuscular function, and that has a rate of restoration associated with it, and if you can put your body onto that path of restoration, you now actually have quantifiable, predictable timelines. So you can, in the same way that you would predict in an accounting world, you can now predict in the biochemical world, in your physiological world, and it's still based upon the exact same principles.
It's so interesting. And this prodrome approach and prodrome science is all built upon this philosophy of restoring health, understanding health. But a philosophy alone isn't going to help Lisa, regain vision after 30 years of blindness in her eye. So what have you built with this philosophy, and how is that actually helping people in real time?
That's where the real frustration came in. Okay, so I started this whole technology back in the late 90s and then started a company called Phenomenum Discoveries in 2000, spent 16 years trying to fit this philosophy into the existing working infrastructure, the existing FDA pathway, get an IND for new drug, phase 1, phase 2, phase 3 trials. And so the problem was when we're dealing with biochemical restoration, we're dealing with the endogenous human biochemical system. These are not patentable molecules. Okay, so all these biochemical intermediates, they're naturally occurring. And so you can patent the use of them. There's no real mechanism. Like you can't really get an FDA approval for health. There's no such thing. So I was trying very desperately to fix or figure out how to make this restorative health model fit into the traditional drug development model. So much so that I invented fake metabolites. I basically take a natural endogenous molecule and actually modify it in a slight way to make it non-natural so that you can get a composition of matter patent, and it would convert to the natural molecule in your body. So I do all these medicinal chemistry tricks just so they would fit into an FDA path. Same thing with the diagnostics. I do have this diagnostic technology for screening colon cancer, for screening for pancreatic cancer, and I had to fit it into this cutoff, like in order to get a diagnostic test for colon cancer, you need to have a positive or negative outcome. And so I spent 16 years trying to fit this into that system. And I realized the system just doesn't work for this type of intervention. So that's why I had to basically do everything from the start.
Because the system is not designed to reward prevention.
Right? There's no model for it. There's no financial model for it. So one of the reasons why we don't have this type of preventative medicine in our world is because there's really no financial model for preventative medicine. Preventative medicine fundamentally prevents something from happening. Like you're actually creating a negative. You're actually, something doesn't happen that is supposed to happen. It takes much larger research models to do that. And the ability to actually implement it into our regular healthcare system, there's no infrastructure for that. Like there's no pharmacy model for prevention. There's no, when you go to your doctor, it's not really there for prevention. You're really, like, they're adding it to their acute care medicine, but it's not really designed that way. It's kind of like an afterthought. And so there's no core structural infrastructure and pathway for implementing actual true preventative medicine.
Because if someone was to build that infrastructure, there's no financial incentive, because delivering that to people would be really challenging. But yet you've done that and you've been building that.
Yes.
So tell me, what you've built with this new philosophy, and what are the components of creating this new preventative healthcare system. It sounds like you had to rebuild the technology. You obviously rebuilt the thought process, the infrastructure, but also the language you use. Tell me about Prodrome and the components of that.
Yeah, so it's kind of like you're pulling a thread, and where does this thread go, if you will, right? It starts with design cyclotron technology, right? So we can identify these biochemical prodromes that predict and show negative outcomes as well as positive outcomes.
Ion cyclotron, meaning this was your invention, but it's
Correct.
Basically a blood test that allows you to look at over 10,000 biomarkers.
Correct.
But that's kind of the first step, is gathering the
exactly.
data.
And we use it for blood, but we also use it for tissue samples, for cerebral spinal fluid. It can measure anything.
Wow.
Plant material, so on. So it's comprehensive biochemistry, depending upon whatever you apply. Obviously, we do 99% of our work is in blood. Then from that, the first core outcome was this plasmalogen deficiency. So the question was, when we were looking at using this technology for people with dementia, notice that low levels of plasmalogens were associated with increased rates of dementia, increased rates of progression to dementia, increased rates of death. And the first question was whether or not this was actually just a coincidence, it was happening in parallel with the disease process, or was this deviation from health, this plasmalogen deficiency, actually in the causative pathway to mental decline and death in Alzheimer's, as well as cancers and Parkinson's and other diseases. And so clearly, a bunch of research was done to show that this plasmalogen deficiency was actually causal. And I wrote a very important paper in 2007 dealing with plasmalogen deficiencies as a causative factor in Alzheimer's and dementia. And there's many patents on this issue. And so that came to the first realization. So clearly plasmalogens were related and there was a deficiency related. So this is the first true metabolic prodrome, if you will, right? So the question is, well, what do we do about it? And so even though we've known about plasmalogens, these are critical membrane lipids. They're in everybody's body. Like your body makes lots of them. It's in your brains and your hearts and your lungs. And so your body makes a lot of plasmalogens. So it's part of your natural part of your body. But as we get older, or if we're under certain levels of stress, our body can't make enough of them. And then that causes this system of our body to become out of balance, becomes having a reduced ability to function normally. So it's reduced functionality. So no one had actually invented any type of plasmalogen precursor or plasmalogen supplement or plasmalogen nutrition that could restore this to normal, surprisingly to me at that point in time. So back in 2005, 2006, I started working on how to actually restore plasmalogen. So one of my other patent portfolios was on this plasmalogen restoration. And then we could test this in a bunch of preclinical studies, cell culture, animal studies, and so on and so forth, and very clearly that restoring plasmalogens or providing a plasmalogen reserve capacity had dramatic protective effects. It prevents demyelination in Cooper's own mice. It prevents Parkinson's in MPTP toxicity. Very, very powerful data, clearly showing that the restoration of plasmalogens or the creation of plasmalogen reserves had a very positive biochemical health benefit in these models.
And correct me if I'm wrong, but from what I'm hearing, you weren't going after plasmalogens. They found you
Correct.
through this new approach of looking at the data and what is the data showing me, right?
Correct.
And then you were like, I can only imagine, what the heck are these plasmalogens,
Right.
and why are they so depleted in these people who are suffering from, cognitive decline? Was that kind of how you found them?
It's a perfect example of a hypothesis generating experiment.
Mm-hmm.
We generated large amounts of biochemical data,
Mm-hmm.
individuals with different rates of cognitive decline, and these molecules came out of the data. We didn't start with, I wonder if a plasmalogen deficiency could possibly be causing dementia. I didn't even know what a plasmalogen was.
Really?
Okay, I completely from scratch. I found these molecules showing up in the mass spectrometry, and I was going, what are these molecules? They clearly have a huge association with dementia. And then from that, the hypothesis was generated was, maybe these plasmalogens are actually related to the disease cascade. And then from there, you test now. Now it became, from that hypothesis generation, now it started a whole series of hypothesis testing, traditional science. Develop a plasmalogen precursor, show that you can restore plasmalogens in a structural way. Then test, if you restore these plasmalogens, what happens when you restore these plasmalogens, and so on and so forth. So that's where the second phase came in. So this whole biochemical restoration part came to place. Mm-hmm. And obviously from plasmalogen, we've now expanded to larger portfolios of biochemical engineering and biochemical restoration for individuals, because plasmalogen is just one of hundreds, if not thousands, of molecules that make up our operating system. But then once that happened, realizing that these are natural molecules that are found inside your body, that there's no real natural dietary source. So we had to design and manufacture. So there's a manufacturing component of these plasmalogen precursors. And how are we going to deliver these things? Okay, it's not a drug, so it can't go through the regular drug pathway unless I tricked it, which I tried. Okay, that was for 16 years. I tried to force it into a drug pathway, which ultimately didn't work. And then Prodrome was started in 2016 after 16 years of really beating my head against the wall about trying to make this fit into a traditional model, saying that we've got to do this differently. And so I redesigned all these molecules for totally natural occurring biochemical intermediates. So they qualify for natural dietary supplements. So anyone can take them. There's no prescription required. And then from that teaching process, we got this biochemical testing technology, which nobody but me and a few small people knew how to do it. Mm-hmm. But doctors had no access to this technology. So now we had this advanced blood testing technology. We had this prototype biochemical restoration program with plasmalogens, but nobody knew about it. Yeah. Right? And that's when I really started building a doctor network. Started with some early adopters that really were interested in neurological disease, did the clinical trial with Dr. Jordan, where we showed we could restore health in people with cognitive impairment. And now that doctor network has grown to over 3,000 people. So we have 3,000. So the next question is, okay, we've got this distribution model, and the financial model is, of course, it's a private pay system with they're charging for their services. They're getting blood testing done.
That is a real new healthcare system. You just said 3,000 doctors are using your testing and products?
Exactly. We've got 3,000 people out there around the world, and they're using these products. They're getting, and that's why you're getting these dramatic results in autism and dementia and Parkinson's and so on. And we're learning from each other. We communicate with each other. We now have an elite doctor network that has more advanced technologies. And this ability to say, okay, I can't keep this advanced technology just in an academic setting, okay, or in a pharmaceutical setting. This actually has to get out into the real world and actually have real doctors with real patients out there testing it, figuring it out, using it, getting results, feeding back their experiences. And from that, we've now grown, okay, from those initial, over the last few years, to the 3,000 doctor network. But now there's a whole group of doctors out there that understand this advanced technology, and they're using it in everyday practice. And so now we can start adding newer technologies into it. So from the plasmalogen precursors, we now have the Neuro Restore package, which has, a complete biochemical restoration. We've expanded the biochemical testing to include a bunch of other biomarkers that are critical for their practices. And now we have this Neuro MRI package, which basically is the most advanced digitization of the human brain, where we can measure deviation from health using the ion cyclotron technology. We can restore biochemical health using this advanced biochemical engineering approach that we use with this strategic supplementation of these biochemical intermediates. And now we can actually measure, obviously we can already measure changes in people's function, like so their functional capacity, their memory, their mobility, their all the functional tests that we normally do, which are powerful. But we're now going into, with the neuro MRI, we can actually say, okay, what's actually happening to the physiology of the human body? And we're starting with the brain because that's obviously we do a lot of neurology related research. And quite frankly, the one part of your body that you want to be healthy forever is your brain. I can replace most everything else, but I can't replace your brain. And we can show now this whole prodrome concept, right, where you can basically predict the future. Once we start fixing the biochemistry, and we've now created this reserve capacity of plasmalogens, but other nutrition, then we have a predictable restoration of brain health. Like for my brain, I've had serial MRIs over the last 3 years, and each year I'm actually rebuilding my brain. And you're seeing this over this longitudinal process. And this is the real power of restorative health. You take Lisa Grillo, right? She didn't start this program and just wake up the next day with vision. It wasn't like an acute fix. It's a chronic fix. Okay, she's followed the program, restored her biochemistry, built up a reserve capacity. Her system now could take that reserve capacity and start rebuilding her vision.
And that was shown. I can tell you, I had a moment where I was like, he is really doing some. I mean, her saying she's regained the vision, already like, whoa. But seeing her brain scan is the before after of just seeing what was that regrowing. Like you could just see the difference. What was that?
Well, it was all of her fiber networks. So all these white matter tracks. So we do this structural connectivity. So the brain scan measures hundreds of thousands of data points in the human brain, but it has a series of different sequences. Looks at the volume, looks at gray matter, looks at white matter tracks and functional connectivity and a whole bunch of things. But those particular things is as her occipital cortex, which was connected to her eye, started becoming reactivated. Once it started receiving signal from her eye, then all of a sudden it starts reconnecting. It starts connecting to these different areas so that she can see that the letter E is the letter E and the letter F is the letter F. And so all that communication from her vision now gets rebuilt. And the brain is really a powerful thing. It's really dramatic to see. And it was, our hypothesis was that if we restore function, if we move away from chasing every disease and every disease symptom and say, you know what, how is the human body supposed to work? Okay, it's designed to work. Like the oligodendrocytes that make the white matter in your brain, okay, they're designed to do a job. So why can't we just make sure they have all the tools they need to do the job they're designed to do? And so we actually provide the cells of the body, the actual materials and the appropriate environment to do what they're actually designed to do. Will they do what they're designed to do? And fundamentally, they do. Her oligodendrocytes start remaking myelin. And
it's so profound because Lisa regained her vision, her body, her health is what conquered that, is what restored her vision.
And she can feel her foot now, like she can feel like her drop foot, and it's just amazing.
But it was her own body that did the healing.
Correct.
You supported her health, and it's like, look what your health can do. And that's why it was called the Restorative Health Summit. All of these people, you were showing the power of focusing on health instead of disease.
It's actually being humble, okay? Science has a habit of becoming very arrogant and godlike, thinking that we can actually do things better than the original design. And so we design drugs, we design things to block a certain enzyme or interact with the receptor. Okay, and some of those things are very valuable. Absolutely. There's some amazing drug discoveries out there that are life-changing for individuals, like certain psychiatric diseases and so on and so forth. So don't get me wrong. I'm not saying every drug is bad, but it is based on the premise that we're going in and we're going to tinker with the operating system. We're going to block this receptor. We're going to enhance this system. Okay, it's not based upon the premise of actually restoring the system itself. Okay, and so we focus on just restoring the system and seeing how far that gets us. And if we can then push it along a bit more, with other advanced technology, we absolutely will do so.
So this prodrome approach
Yeah.
includes the ion cyclotron technology that's looking at the biomarkers in the
Mhm.
blood, and apparently you can
Yeah.
also use it for other things as well. The plasmalogen precursors and other components of this neuro restore protocol.
Yeah.
You also have the neuro MRI, where you're able to track and monitor the changes in the brain structure and function. You have a doctor network implementing these research grade tools to people in real time. Which one of those elements do you think is making the biggest difference today?
Well, clearly the plasmalogen precursors are the big hammer in this scenario. It's a critical nutrient that for somehow over decades have escaped our attention. And I was in the right place at the right time with the right technology to discover these things.
Mhm.
But really, these plasmalogen deficiencies for brain shrinkage and brain restoration and neurological, absolutely critical. And it creates a conversation. Okay. It's a very powerful component of the restoration package, but it's not the only thing. Okay.
Mhm.
You still want to restore your mitochondrial function, methyltransferase. So it actually creates this anchor from which we can build around it. And we say, okay, this is our beachhead. We're going to start with this and move forward.
Yeah.
And then you get results.
Mhm.
People get real, meaningful, observable results. That motivates them. It
Yeah.
motivates them to go to the next step and say, okay, oh, I'm getting some benefit here. What more can I do for you?
It's interesting because to me, the plasmalogens, hearing how you even discovered the power of plasmalogens is really just proof of concept of this whole prodrome approach.
Yeah.
And they're kind of just the beginning.
It's just the beginning, yeah. And then it leads to different aspects, right?
Mhm.
So clients come in all shapes and sizes and all different levels of health. Some people are healthy and they just want to maintain their health. Some people are actually in the throes of a serious debilitating disease
Mhm.
and they need more help. And so part of our job now is to say, how do we provide service to the population at whole? We have an inpatient clinic that people can go to. Our elite doctors, they can actually send to the clinic their patients for a month, and will come in. They'll get all set up. They'll get a restorative program. Because restoring health is a protocol and it is a lifestyle habit forming process, right? When we're talking about longevity and we're talking about maintaining perpetual health, you need to create patterns and systems in your everyday life that you can perpetuate every day. Like you have to follow these things. And our lives and our lifestyles aren't always conducive to the long-term, boring day after day process. So helping people get their lives in order and get them a leg up, if you will, and then they can go home and then continue those programs is very, very important. I think right now, medicine, the other big problem with medicine is that we just don't have time for people, right? You come in for a 15-minute doctor visit, they give you a prescription, they give you this, go away, it's your problem now. I won't call you, you call me when something's wrong.
And that's all back to the system. I think
Right.
I think doctors probably wish they had more time to connect with their patients, but
Yeah.
they're working in a system and that's the way the coding works and all of that. But something I'm curious about is after having this extraordinary breakthrough with plasmalogens, why not just stop there? Why, was there something that pushed you to say, I'm going to now rebuild this entire healthcare system from scratch, and I'm going to focus on building my own preventative healthcare system? Because that is a huge undertaking.
Yeah, if I had to really pick a moment in time,
Mhm.
obviously things were brewing for years, if you will, right? But it's rare disease in children, this very specific disease called rhizomelic chondrodysplasia punctata. These are children that are born with a genetic defect that prevents them from making plasmalogens. It's life-threatening. Well, it's not life-threatening. It's actually terminal disease. Most children, if it's a severe um, defect, they die within the first few years of life. If it's a minor defect, they may live into their teens, but their quality of life is dramatically altered, okay? And it's all caused by this inability of their bodies to make plasmalogens. And we actually have, at the time, at Phenomenal Discoveries, I had 3 patent series, very clear molecules that could restore plasmalogens, that could restore health and vitality in these children. It was obvious. And it's pretty obvious now if you take a look at Thatcher, Nova, and many other children. Like this technology works for these children. And it was very obvious that it would work even back then. This is back in 2015, 10 years ago, 2016. Okay. And it became clear that under the financial model that a regular biotech company works under. This wasn't possible to deliver to these kids because the value of the drug was too much for this easy implementation.
When you say value of the drug, what do you mean? How much would this drug cost?
The market price for a drug for these children that has an effect is $400,000 per year per child. Okay. And if you are to develop a drug for those children, you get a voucher from the FDA called Pediatric Rare Disease Voucher, which is worth another $200 to $400 million. And so it's extremely lucrative. The problem is, because it's so lucrative, no one will develop a drug that doesn't fit within the parameters of that rare disease program. And so if you have a drug for Alzheimer's that works for a child, doesn't qualify. So you don't
It
get
would be off-label or something?
You spend the regular price for the Alzheimer's drug. And so what happens then, so this situation with the RCTP is clear, it's one very glaring example of if this is what's happening in my world, the world that I have true visibility on, how many other therapies, simple, effective therapies are not being developed in our world? How many for other diseases like Parkinson's, cancers, how many of these other programs are simply not being developed because they don't fit the financial model of the drug industry?
Wow.
Okay. And so it can't happen just, am I just the only person in the world that this has ever happened to? Mm-hmm. And so that clearly indicated that we need to redo this from the bottom up. We need to do it in such a way that we have our own network of doctors, which we have now. We have technology that's fully accessible by everybody, okay? And people can work together to really rebuild their health and have access to these technologies. And so from the bottom up, I basically destroyed all my patents and basically redeveloped these molecules as natural biochemical intermediates of biochemistry, so they don't fall into any kind of they're natural supplements. So you can't be stopped from taking it.
And it really stuck out to me that you have a rare disease foundation that gives the children with RCTP free therapy.
Correct.
And the cost of a therapy would be $400,000 if it wasn't for you and your program and the system that you've built. So that is just so amazing.
What kind of society do we live in where we can't actually cover the cost for 100 freaking kids?
Yeah.
Like seriously, like we're dealing with thousands and hundreds of thousands, millions of people with dementia, and we can't actually just donate to 100 kids. Like
who really need it.
It's ridiculous.
So you're supporting those children through your charity and your efforts. But back to Prodrome science at large,
mm-hmm.
How does this work economically? Like who is paying for these technology and these products, and how does that work?
There's two pathways. The first pathway is the initial pathway, which is a private pay system. Mm-hmm. So people with means can hire one of our doctors, okay, get a functional medicine doctor. They buy the supplements. It's all cash accessibility for individuals. So all this technology is available. The MRI technology, mm-hmm. the ion cyclotron technology, the plasmalogen technology, everything is publicly available to anyone who wants it, okay? And that is the first pathway. This is where we're growing the marketplace in this private pay system, okay? Then the next step is obviously a lot of people will not be able to afford these programs because, a lot of the population is, underserved. So the next step, of course, is how do we create the financial model? So here's a clear financial model here. It's like buying sneakers at the store. It's yours. You buy your product. It's, and if you like it, you buy more of it. It's straight. It's a simple commercial model. But we're dealing with the actual health now and the health consequences of things. And so where do you actually drive the larger financial modeling to incentivize true infrastructure development? And the real financial model there is in healthcare savings. And the value of healthcare savings is exponentially higher than the actual cost of these programs to individuals, okay? And so take a child with autism, okay? A child with autism, the lifetime cost is around $3.6 million, if not more. Okay, that's
wow.
$3.6 million. It's a lot of money. And you take a dementia patient, from a diagnosis of dementia to death, it costs the system at least $500,000. Okay. And those are not just direct costs, but they're also indirect costs related to an individual that lost work, the caregiver structure, the disruption in the family, the loss of economic viability. There's so many other issues and impacts it has on our lives. And the good news is that these health economics have been well documented. And one thing that we do extremely well in the healthcare system is measure how much does a bipolar patient cost per year. Like, we know these numbers with extreme accuracy. And so our ability to prevent and actually quantify this restoration of health has absolute direct monetary, measurable monetary value to it.
It seems to me like we can't afford to not shift our focus and do it this way. It's just inevitably going to crash. I mean, $3.6 million is the cost on the system with one child with autism, $500,000 with someone with dementia.
Yeah.
We have to use this prodrome approach to stop these things before they happen.
We're crumbling. We're crumbling under this program of chasing every disease down. We can't afford not to do this. And it's time. It's time. Like, the current healthcare system is still an amazing system for acute care disorders. Okay. Our ability to prevent premature death is very, very good. Okay. The system isn't designed for long-term restorative perpetual health. Okay. It doesn't deal with chronic diseases well. And we're asking a system that was designed to deal with acute emergency-based medicine. We're asking them to refit themselves for this chronic care. And chronic care is messy. It takes time.
Mm-hmm.
It's lifestyle, it's supplements, it's nutrition, it's testing, it's community. Okay. And so we need to actually engage people, actual humans, in their own health and reward them for their own health. And there is such an amount of healthcare saving. There's such a financial incentive to reduce disease burdens that we can actually pay people to be healthy.
Wow.
Like, rather than this actually costing the individual, you could actually write individuals paychecks for being healthy. Like, you can actually pay them to be healthy because they're actually saving all of us money.
I've heard that some actual traditional payers in healthcare systems are starting to, subsidize healthy groceries, and like they're slowly getting there, but they're not doing that just to be nice. They're doing that because you are going to save a health insurance company a lot of money down the line if you take good care of yourself. So I love that vision of a world in which you could actually reward people for making healthy choices. And what is your larger vision for the future?
And that's the empowerment of people. Okay, getting people more empowered with their own health. So we have this large private network of doctors that's growing rapidly, right? And there's always going to be a need for people with specialty services, period, no matter what you do. But for the larger whole, I've created a community health program called Moose Jaw Vitality Project. And this is really teaching us how to engage at a community level, at an actual geographically defined population. So Moose Jaw, Saskatchewan, which is my hometown, there's 35,000 to 50,000 people. It's just a regular city in North America, nothing special about it. It's an agricultural community, probably at the lower economic group of cities in the world, and geographically defined. So we're setting up a research facility, advanced 3T MRI, CT scanners that can measure plaque growth, cardiac ultrasound, advanced blood testing, cardiopulmonary testing.
You're bringing all of that technology to Moose Jaw,
Moose
Canada.
Jaw. And we're bringing manufacturing right there. So our nutritional manufacturing will all be done in the city, creating, economic growth in that. But we want to create our own blue zone from scratch. And you can't just force it upon people. People need to be part of it. They need to feel empowered by it. Okay. They need to see their children getting better. They need to see their parents getting better. Okay. And they need to be part of it. And it's a labor intensive process because you're talking about food and catering and actually being involved and talking to people, actually having a conversation with people about how your health, how your life, how the quality of your life can benefit by doing this. So if we can start creating community where people can actually be proud of their health and actually, heck, make a reward system out of it where cities can get extra funding if they if they get there. So that's where my bigger plan is. And then that's where these programs become free of charge. Okay, they become programmatic. And but we need to teach people. We need to teach the world. We need to teach, what we can, once we develop this program in Moose Jaw, then it can be moved to other cities or other states and say, okay, here's how we do it. We set up, here's the community service model. Here's what it takes to actually to do this. And it's a win-win situation for everybody.
And it's bringing the open access of these research grade technology, but it's not just that. Yeah. It's the community, it's the protocols, it's everything together. And I think that's so amazing that you're going to start with your hometown. And if you can improve the health outcomes in your hometown, I can only imagine that is proof of concept, to bring that to other places. And that will then allow it to be, free for people.
Exactly. It's 100% voluntary and 100% free. And it's our job to create this win-win scenario. And if we do a good job of educating and good job at actually creating improved quality of life, then people are going to want to be part of this.
Absolutely.
And that's our model.
I can't imagine anything more innovative than building a preventative healthcare system from scratch. I think the healthcare system has done a lot for many people and saved many lives. But the time we're in now, where the chronic conditions are really causing the most stress and harm to people over their lifetimes and really affecting quality of life.
And a celebration of life itself.
Yeah.
Okay, people start feeling that life isn't worth living. Okay, we have so creating a celebration of making life worth living. Okay, the emotional part, getting people working longer, getting people jobs, getting people engaged in their world. There's an emotional component where these chronic diseases, they strip people of their will to live and their will to contribute. And so the other part about this is getting people engaged in their world and actually celebrate the life that we have and build on that. I think we're creating a world of sickness, and that world of sickness is suppressive. People don't feel energized. They don't feel excited. They don't feel like innovating, right? If you want an innovative world, you want people thinking about the newest, greatest, best thing in this world, they need to be healthy. They need to be invigorated. Their parents need to be healthy. Their kids need to be healthy. They need to be able to want to get up and contribute to their world, okay? And if you're living in a world that's full of sickness and full of hate, okay, you need to kind of re-engage people, because that's also, it's not just your health, it's the entire economic purpose of living that you can start, reigniting in people.
What's that quote that you say about putting love back in?
Yeah, you can't just take hate and expect love to be there. If you want more love in your life, you got to put more love in. We just can't remove negatives in our world. And that's a big thing about this restorative health. People think of removing symptoms, removing toxins, they're always trying to detoxify their world, when clearly you want to remove toxins and you don't want to be in a toxic relationship. You don't want to be in a toxic environment. That's obvious. But if you want a loving relationship, okay, you have to put love in. And if you want to have a loving relationship within your community, you got to put love into your community. And together we do that. And I think that's where this whole restorative health, the whole biochemical approach of restorative health, is that we add health back in. We add plasmalogens into your body. We add the biochemical intermediates that your cells need to work. So just like making sure that the oligodendrocyte has the building material and the ability to make myelin, well, the baker down the street needs the same thing. Okay? He needs a healthy child. He needs healthy parents. He needs a place, to feel at home. It needs to feel safe and available to do what he's doing. And so we ourselves have the same type of concept. So if we want more out of our communities, we need to put more in. Okay, we just can't, it's not about just kind of protecting us from all these outside sources. We need to roll up our sleeves and actually put stuff in.
Yeah. And you saying the roll up your sleeves part was exactly what I was just going to hint at, which is that this is a beautiful vision, but I believe if anyone can do it, it's really you, because you've already walked the walk. You've already restored health in so many people. You're, buying the MRI scanners. You're bringing this technology to your hometown. It's happening.
Yeah.
You don't just talk about this happening. It's happening.
It's happening.
And, this is really just the beginning, and I can't wait to see what you create. I'm happy that the USA Today has caught on to the innovation that you have brought to the world, and I can't wait to see what's to come.
Yeah, it truly is an honor, and I really appreciate the writers for that offer, that honor. So thank you.
Yeah. Thank you, Dr. Goodenowe.